Solve the following simultaneous equations by an algebraic method. Surely working. Now you notice here we've got two equations, and as it says, we can just solve them simultaneously. Okay. Now the route we go by often is just to look at what values here are in front of the y's. Okay, this second term here. Now notice there's a 2 there, and there's a 3 there. I know it's minus 3. Okay, and it is minus 3. But ultimately, I'm just interested in the actual numbers that are there, written there, 2 and 3. So what I do then is, okay, I need to change these equations so that I can actually work with them and work out what x and y is. So what I'm going to do, I'm going to times the first equation by what's in front of the y in the second equation. So you'll notice now there's a 3 in front of the y. And as I said, I know it's minus 3, but I'm not worried about the sign. I'm just going to look at what's in front of the y here, which is a 3, and times that first equation by 3. I'll then take the second equation here and times that by what's in front of the y in the first equation. Okay, so there's 2 there, so you times it by 2. So you kind of like, it's kind of like swapping them, isn't it? Vice versa. The first equation times by what's in front of the y in the second equation, and the second equation by what's in front of the y in the first equation. So if I times the first equation by 3, okay, timesing by 3, well, you've got to times everything by 3. So 5x times 3 is 15x. 2y times 3 is 6y. And 11 times 3 is 33. Second equation then times by 2. 4x times 2 is 8x. 3y times 2 is 6y. But of course it'll be minus 6y. And 18 times 2 is 36. Okay. So I've now got two equations, right? But what's good about these two equations is the value in front of the y is the same. I've got 6 in front of both of them. One's plus, one's minus. And the fact that we've got 1 plus 1 being a minus, we can actually now get rid of them. We can eliminate them, okay, by doing a simple bit of addition, okay? So if I call this, say, equation 1 and this equation 2, and what I want to do, I want to add equation 1 and add equation 2 together, right? So I add them together. Literally, you just go in columns, you see what's there. So you've got 15x and 8x. That adds to 23x. Yeah, because 15 and 8 is 23. Now watch what happens here when we add these. 6 add negative 6 just becomes 0. It disappears. Okay, so 0y is just 0. I don't need to write it down. And then if I add these, I get 69, I think. Yeah. So you've got 23x equals 69. Notice there's no y there. It's all gone. Okay. So what I can do then is work out what my x is, all right, quite simply by noting I've got 23. Let's write that a bit closer. 23x equals 69. Notice now that this is 23x, that means 23 times x, yeah? We multiply. And if we multiply, when we take it over the other side, we divide. And you can divide that, right? And if you think about 23s, it goes into 69 3 times. Okay, so we've got our value out for x. Now to get y, all I need to do now is substitute this value of x into any one of these equations. Doesn't matter which one. So maybe I'll put it into the top one. And notice there's 5x, yeah? Well, 5 times x, that's what that means, isn't it? So I'm going to do 5 times 3, because that's what x has become. Plus 2y, it says then, equals 11. So I can work this out then. 5 times 3 is 15, plus 2y is equal to 11. I've got myself an equation now where I can take the 15 over the other side. It becomes a minus 15. So 2y then equals to minus 4. And I work that out. And then y is minus 4 divided by 2. And we can all divide 4 by 2. We get 2 because there's a minus there. It becomes minus 2. So I got my answer for y as well as my answer for x from earlier.